Our next speaker is Marcus Eagan. He's a product manager for MongoDB. Formerly worked at Ford, LucidWorks, and Apache. He's from San Francisco. He studied data science at University of Michigan. Oh, I had a boss that worked there. And he considers himself an open source visionary. So please welcome Marcus. Thank you.
Thank you. I think, just to clarify, I think I may be the only person that considers me an open source visionary, so bear with me here. But happy to see everybody. As previously discussed, I'm a product manager at MongoDB. Most people probably didn't know that MongoDB had thousands of paying customers and a search engine that's managed in the cloud on 3 cloud providers, multi-region, and uses Apache Lucene. People think about us as this open source community document data store, but there's more to the story. Now, who am I? I'm a hacker turned PM, but I did live in Atlanta for a year because I built a cybersecurity company focused on IoT, and it was acquired by a company here in Atlanta led by Paul Judge. So if people are from the area, you might know Paul Judge. He's done a lot for Atlanta tech community. And he actually wrote an article on support vector machines for predicting malicious hosts. And I implemented something that was a support vector machine for predicting malicious hosts. So it was cool to come to Atlanta and cool to be here at Southern Data Science Conference. I went to Grinnell College, didn't go much. Went to Michigan, again, didn't go much. The great places. Then I worked at a small car startup, Ford Motor Company, doing like very large scale recommendations. LucidWorks, there's a lot of LucidWorks people here. A lot of people here know LucidWorks. And now I'm really focused on democratizing access even further, right? So that's why I came to search, and low code is another thing I'm really interested in, making it easier for us to do our jobs here in this building. Now, some of the projects I contributed to, I just dabble in a lot of areas. I think most people here are familiar with Airflow. I try to work on accessibility, screen readers. I think a lot of people here will recognize some of the other products here or projects here. But if you're interested in any of them, let me know. I'd love to talk to you about them. I'm still contributing to a lot of open source projects as a part of my job and really enabling builders. Now, this talk is really about a conversation with your users. Because at the end of the day, that's what search is. If you think about what someone's doing when they visit a digital property, or maybe even talk to a voice interface, really what they're doing is searching. And these interfaces are difficult. I asked you a question, I didn't get an answer. I guess you didn't notice that I asked Alexa twice because it's the same background. But I'm trying to get this information. How does it happen? Lucene. So I don't know what time it is, probably wrong, a little early. But Apache Lucene is powering Amazon Alexa. It has been for its entirety. And I think people think there's a lot of magic, and there is magic, but it's largely lexical. There's obviously named entity recognition. There's some transcription service. there's a wake word. So there is some magic, but Lucene has always been a vector database. Sparse vectors, when you think about like a field-centric approach to search, if you know the location, and so you know the time zone, and you know the time of day, like these are vectors. They're not really dense vectors. This is what search ultimately means for Amazon, and this is why it's so important to everyone here. It's like this, so we all stay employed. And a lot of the revenue at Amazon that is tied to sessions with search is about the filters on the side. Lucene facets, you probably are familiar with. Most people here are familiar with facets in search. That is a strict lexical filter criterion in most cases. I mean, there are edge cases where that's not exactly how the facets work, but facets are really driving a lot of the browse and product discovery. I don't want anyone to lose sight of that. Now, what about if the answer that your users, the answer to the question that your users pose isn't in the documents, isn't in the body of knowledge, isn't in the corpus that you have? Well, that causes problems. There's common strategies for dealing with this. They're all annoying. One of them is synonyms, right? So many people here have worked on synonyms, heard talks about synonyms. If anybody here has managed synonyms, they can all tell you it's a pain. You have to re-index in legacy systems. In Atlas Search, you don't have to re-index a finite state transducer at query time, but that's like, the reason why we did that is because we want synonyms to be able to be automatically generated and can change on the fly when you need to change them. I'm not here to sell you on Atlas Search. I'm really here to sell you on something far more important. But ads, that's a terrible strategy. Like sponsored content, I just avoid it even if it is relevant. It's like, I don't want to give more money to this so they can raise the prices. I'm going to find it organically. And also fallback content, one of the strategies that some people employ is if we get 0 results for our queries because those are so expensive to our business, we'll just show anything. It's like ridiculous. So I want everyone to go on a journey with me. I want you to imagine, because we all shop online now since the pandemic. Imagine we're walking into a retail store again, okay? I don't know what your favorite one is. I'm not gonna start a fight between Home Depot and Lowe's because one of them isn't here to defend themselves. But imagine we're in a retail store. Close your eyes if you want to. I'm afraid to fall off the stage, but I've closed mine. Now, imagine that you need to spot the salesperson on the floor. I mean, this is so awkward. You get to the store, you know what store you want to go to, or it's awkward for me. I hate shopping, so maybe I'm really telling everybody about something I have a problem with. Go into the store, see a salesperson, now I have to try to jog up and catch them. And still, because of the pandemic, I'm not gonna touch them. I'm just gonna try to awkwardly get their attention to care about me. Okay? So, find the salesperson. Hey, salesperson. I need to get your attention. And I want to know where the anti-ball crushers are. You know, there's this there's this big campaign, Lululemon's trying to break into male athleisure. And so they come out with this ad campaign, it's racy, it's like anti-ball crushers. Anti-ball crushers. And I'm like, that's a really good name. I like that name. And my friends are like, yeah, I gotta get these. I'm actually wearing some right now. I just have had them forever. But like, walk into the store, ask the person for the anti-ball crushers, and they're disgusted because it's a lewd thing to say to somebody if they haven't indexed this product in their corpus. And you can imagine that in the taxonomy, in the product catalog, the company just put in ABC pants. Even the person who put the data in the product catalog didn't put anti-ball crushers. Nowhere, not in the description, not in the title, but they have ads on YouTube and they have people talking about it on Instagram and influencers and everything. And so I'm in the store pissed. Like, I asked for these pants, she never came back. Like, that is how it feels. You're just standing there, you don't know what's going on. Maybe if you need the anti part, you might be uncomfortable. Like, I don't know what's going on. When I search for something and nothing comes back. This is such an expensive problem, okay? It is really important to like try to solve it and to think about it. And like at MongoDB, we mostly focus on application search, like search that human users consume. So like we power a bunch of grocery stores and delivery platforms, just like app stuff, not like logs and not too much analytics, some. But we really focus on application search. So zero results is a big problem in our customers. Now, we're introducing a simple mechanism for improving that conversation so that when people come into the store and they ask a question, they get a response because it's just rude or, for me, frustrating because I'm confused in stores and on websites, frankly. Now, the feature we're going to talk about briefly is not the end-all, be-all feature. It's not something you need to go re-platform for. It's not even super complex. The math behind this feature is 5,000 years old. So I really don't want people to think that this is super complex. And I also want you to trust me, right? You will hear people always talking about all the new bells and whistles and the fancy new thing and what a VC invested a bunch of money into. Trust me, they don't know what they're doing most of the time. Some of them, I should say. Some of them are very good. But we're not talking about a very complex thing, really. And we're working with life sciences companies, manufacturing companies, financial services companies, and companies doing things that I never thought was possible. And they'll be doing more of that with this feature I'm going to talk to you about, vector search. But I really don't want you to walk away from here and say, oh, vector, shiny, gotta go use them. Because they appeal to us as technical folks, right? It's a concept we understand. It's a numeric, unified data format, like for a lot of use cases, but it's not gonna solve every problem. Now I'm gonna show you a demo.
We're going to take a look at sample influx movies.
IMDb.
Now, in the movies, you can see we have the full plot vector and array of floats here. I believe the index name is Paul. And too many ends. The path is full plot. Value of K here is going to be 5. And let's try the Nike path and study Nike query inspired by that. So there's no synonyms defined. There's no match here, but if you look at this plot, the plot here is about a 14-year-old who becomes an NBA superstar after trying on a pair of sneakers worn by Michael Jordan.
Now, I'm assuming everybody in here knows a few things and why this happened. I mean, you know how semantic search works conceptually. Everybody's talking about it. A lot of people here are data scientists. Most people took geometry, linear algebra, statistics. They understand the foundations. But when you think about it in the context of your business, and also you probably know that Nike is the majority owner of the Jordan brand. Michael Jordan's shoe brand. It's like a multi-billion-dollar brand. So there is a clear semantic link between Nike and Michael Jordan, and probably basketball, frankly, and shoes, right? That was a small data set, 25,000 or so documents, sample data set. It's very beneficial, maybe if you have a cold start issue, you don't know what your synonyms should be, or you're overhauling a system, or you're just trying to do business, just trying to get by and respond to natural language input from end users. But that query really isn't complex enough for most use cases.
We're going to...
This system that you can see the architecture diagram for here, it is set up for most sophisticated use cases because what we've done, and I won't spend too much time on this slide, but what we've done is we've packaged MongoD, the MongoDB database, MongoT, which is a really intelligent process that manages indexes, parallelizes ingestion, and the automation capabilities of Atlas, auto-scaling, and wired Tiger cache to bring like the power of lexical and semantic search and Lucene to strongly consistent data store in MongoDB. And I know people, I hear all the time in the Bay Area, won't I lose my documents if I use MongoDB? Been like 7 years, brother. Like, in fact, if you all remember Sleepy Cat, the storage engine that Oracle uses today, still, well, it has a younger brother called Wired Tiger, written by the same people. They work at MongoDB now. And so Wired Tiger has been a part of MongoDB for 7 years. It's really robust and powering some of the world's largest workloads, challenging the scale of the cloud provider's ability to provision nodes in time. I mean, big workloads. And Lucene is even more robust for its use case. I mean, or more mature, I should say, not robust. They do different things. But Lucene, has been around for over 20 years. I think everybody here has used it, or if you use Wikipedia, you've used it, right? Or Alexa. So, or Siri. It's very robust. Because of these advantages, the semantic search data workflow is actually simplified. Like, you load your data in Atlas, takes a few minutes, and you can quickly add encoding into your pipeline, into your workflow. There's TensorFlow Hub and PyTorch Hub and Hugging Face, which I think has done a tremendous job at really making these things accessible, were a big part of why we made the decision to actually offer this feature to our customers. Like, I'm pretty involved in Lucene, and I saw when the work started, Lucene 9004 in like December of 2019. But it wasn't simple. People were gonna spin their wheels and work forever, and our customers need to move fast. And so we have to make things simple, and they can iterate on them. We have people who go very advanced and very deep, but you have to be productive. Otherwise, we will lose momentum. Like, there were years when data science was like a cost center. People had them, but they didn't really use them. They had them, but they didn't really understand them. They had one or two, but they sat way back over there in that other building, in that other place. I don't even know what it's called. They have PhDs, who cares? Like, this is our moment. We have this moment where we can take our skills and drive direct value to the business that's easy for them to understand. Them being the non-data scientists, sorry about that. Not them versus us, but kind of. And this is how simple it is. Like, this is the genius of Atlas Search's simplicity. It's not that remember the math behind this is 5,000 years old. We expose 3 similarity types, and they're based on Lucene, is Euclidean distance, dot product, cosine similarity. Euclidean distance is probably best when you don't know the length of your vectors. They're not gonna be standard number of dimensions, right? Or cosine similarity is gonna be best when magnitude doesn't matter. But if your magnitude is normalized, dot product and cosine similarity are the same. So you can use any of those 3. I think in most modern programming languages, those similarity functions are 1 line of code. There's some magic happening on the back end in Atlas Search to really realize the benefits of this, so you don't have to spin up a bunch of new infrastructure, talk to a bunch of new vendors, and add a ton of complexity. There's the evolution. Bag of words, still very important today. We're talking about managing synonyms. TF-IDF, still very important today. Jumping forward to MUM, we don't even know what it does all the way. So you can't rely completely on this. Be productive, have control, feel autonomy, drive business value, get more investment from your company to spin up more TPUs or GPUs to train models, or to grow the data science team, to invest more in these intelligent apps. When should you use the lexical approach versus the vector semantic approach? You should probably use them both all the time. And many times, TF-IDF is fine. The term indexes and Lucene are great. Fantastic. I want to end with just that it's only part of the story. There's a lot more that's super important to getting this right and to adding value for your business. It's appealing to us because of the unified format. It's numeric, it makes sense, supports multiple modalities, right? I'm telling you, I've tried with audio and vector search. Doesn't matter what vendor you use, it's hard because of the transformation when you compress sound to a dense vector, because it's a very, very dense vector naturally. So, it's not a panacea for your relevance problems. It's just not. If you want to try the simplest, fastest way to market using vector search, you can email me. This is my personal, my work email. I don't give out my personal email. And I just want to take just 15 seconds to recognize Dr. Chao Han, who was VP of Data Science at Lucidworks when I was there, and we lost her during the pandemic. She was very influential in the information retrieval and particularly in synonym generation. So if we could just take 15 seconds. Thank you for your time. And,